Hi everybody, Kent March with Explore Scientific. Welcome to today's broadcast here on our social media platforms. Today we're going to be talking about the First Light doublet, 640 millimeter, 80 millimeter in diameter telescope paired with the EXOS 100-02. This item right here is a great go-to tracker. It's designed for small telescopes and especially for cameras, DSLRs and camera lenses, so you can do go-to and tracking of the sky, following the stars or the sun or the moon across the sky and take pictures with it, or as it's set up for right here, just visual. So you can just make it go to the object you're looking for. There's a process to get it lined up. You have to have this lined up with your polar axis so it's pointed north towards Polaris. Be able to see Polaris in the telescope and then do a quick 2-star alignment and off it goes. So this is $649.99 available. The telescope comes with a red dot finder, with a super Plössl 25 millimeter eyepiece that gives you nice wide field views of the things up in the heaven. The EXOS 100 comes with 2 counterweights, has glow-in-the-dark markings on the legs that makes it easy to see at night. It comes with the computer brain here, and it also comes with this nice sturdy yet light travel tripod. It is designed to be easy to go places and to carry it with you. The generous 80 millimeter, 640 millimeter focal length telescope pairs up really well with this combination. It's $649.99. Also comes with a phone holder, so you can mount your smartphone onto the eyepiece here and take pictures of things with your smartphone device. Now, how this runs is real simple. I have a battery pack that I just turned on. We'll talk about that here in just a minute. It runs off of a Windows laptop or desktop machine connected wirelessly through Wi-Fi, or with an Android tablet, or like I'm using, an Apple iPad. So I'm going to go ahead and open up the iPad, putting in the password, and all I'm going to do is I'm going to see if I can do this upside down. I'm going to go to my settings. I'm going to go to Wi-Fi. There we go. I'm going to wait for the mount to pop up, and I checked to make sure which one it was, because we have customers, engineering is right behind us, and their units sometimes are on. I'm going to connect with that one. The password you put in is very simple. It's capital P, capital M, capital C, dash, capital E, lowercase IGHT, so PMC-8. This is named after the PMC, Precision Motion Control 8 processor, which is 8 processors right here in the brain that tells it where to go. So now we're connected up to the Wi-Fi. Yep. And so I'm simply going to launch Explore Stars, which on the Apple is a simple, easy download. You just plug it in and off you go. So theoretically, I'm connected now. And yes, there it goes. So I'm simply going to hit Menu, and let's do Settings. We're going to do a 2-star alignment. We can't see that star, so we'll say we're going to go to, okay, we can see that star in Ursa Major, and I'm going to simply tell it to go to. Hard to do sort of upside down. And as you can see, assuming that we have a good polar alignment, the closer you are, the better it's going to be at pointing at the object. And so we're going to let it do its thing, and it's going to do the math for us, and it's going to point to this specific star in the handle. I'm getting the glare in the handle of the Big Dipper. You can see right there. Then we would look in the eyepiece and tell it to move with the left, right, up, down buttons. I'm going to set it at a speed of 5, and we're just going to move it a little bit, and we're just going to get it centered up in the eyepiece. We're going to get the star centered in this as best we can in the eyepiece. We're going to hit enter, and then we're going to go, say we can't see that star, we will move to another star, and oh, let's see. Yeah, we can see that star in Perseus, so we're going to tell it to go to, and it's going to go to another part of the sky. Generally, it tries to go 90 degrees away from where it was, so it gets a really good triangulation, and it models how far off of north polar alignment we are. So it's going to swing over, and it doesn't show us where it is in the sky, it just goes to that spot. And when it stops, we know the vicinity of where it is. So once again, when it stops, we're going to look in the eyepiece, we're going to see the star, and if you're off a little bit, you can use the red dot finder to see, okay, that's where it is. Get it centered up by moving left, right, up, and down a couple of times, moving it left, right, up, and down, getting it centered up. We're going to hit enter again. We're going to hit enter again. There we go. And now we've created a mathematical model that shows how far off of a good polar alignment we are. It utilizes that to make this now go to where it's going to go. Monday night I was at a star party out of the school and set it down. We polar aligned it pretty well, not great. And the science teacher who had bought them out, she did a 2-star alignment, and then she went to the moon. Let's see if the moon's up. So we're going to go to menu, and we're going to go to catalog this time, and we're going to select solar. There we go. And there's Mercury. Where's the moon at? The moon is right there. Let's see if the moon is up. The moon is not up because it doesn't say slew to. So we're going to go back to the menu page and back to catalog. Let's just go to the sun and hit slew to object. And I have this set up to also have to hit go to make it work. And now we're just going to go off to the sun. Monday night when we did it, she went straight to the moon. It centered the moon in the telescope. Later on, we went to M42. M42 was dead on. And then we went directly overhead to the Andromeda Galaxy, which was directly overhead. Very difficult place for some mounts to go. The Andromeda Galaxy was off-center by about 1/4 of a degree in the eyepiece. And everybody was just wondered, it was wondrous, and we're amazed at how accurate it was. It all depends on getting it set with a good polar alignment through this polar axis right here. So this is the First Light AR8640 IEXOS 100, available right now on platforms, and we're going to let it finish up. Obviously, we're not going to look at the sun with this telescope because we don't have a good solar filter on it, but we could test it with the lens cap on. We could see if the shadow is really sharp and crisp and see how well it's pointed right at the sun. So let's go to something else. Let's pick, let's go to Messier objects. Let's go to M2, not sure where it is in the sky. Here we go, it's in the constellation Aquarius, I know that. And here we go, we're gonna go somewhere else. Fantastic little product here. And it's very quiet. You can hear the noise. Some people will have asked us to turn that music off. They don't know why we programmed it to make music. That's not music. That's the sound of the stepper motors and the circuit board doing its thing. So this is run by stepper motors, which count micro steps, not DC servo motors where you have to count flashes of window with a encoder situation, which gives you much more fine control of the motors as they go. Also, we have the circuit boards allow us to put torque settings on them, so if it runs into something or binds up, it'll make a pretty chattery noise, but it's not doing anything. It's simply the circuit board letting go of the digital motors in the magnets, and it just goes cha-cha-cha-cha-cha-cha like that. doesn't do anything other than lose the micro step counts. Then you just have to go back to the home position and start all over. Figure out why it did what it did, probably because it was out of balance. So it's almost gone to M2, which is in Aquarius, and M2 is a globular cluster. So now we're done for the night. Menu, settings, park, and it will go back exactly where it came from. This is a great entry level and high end. That's the great thing about it. We engineered this for both entry level, easy to use, but also high end astrophotography is capable, is it with easy within reach with this mount, with a telescope and a DSLR camera that you have. You can connect this mount up wired to a computer and run it with other programs. You can also put a guide scope on, and the guide scope will do a great job of keeping the telescope pointed exactly where it needs to be in the sky. The guide scope will talk to the brain, to the PMC-8 controller unit right here, and take care of it. This is $649 right now. So I'm going to shut this down on my iPad, and I'm going to talk about, I'm going to turn it off. Now I'm going to talk about how we're powering this. This is the Explore Scientific lithium ion battery pack. It's $139. It comes with the exact tips you need, guaranteed to work. We'll get calls from people who buy a lithium ion battery pack from somewhere, and they'll buy the $3.99 tips, and then they can't get it to work, and we'll say, how do you know your tips are the right? And we'll end up sending them a battery pack, and their problems are solved, and they buy the battery pack and wish they hadn't bought the other battery pack that wasn't made specifically to work with our PMC-8 go-to system. So this has a 8,600, I believe, amp hour. It's 129. I have a friend who lives in California, and the heavy snows they had a couple of weeks ago, he has a couple of these, and he said these things saved the day, allowed him to keep his devices charged up, his LED flashlights charged up, his phone charged up, his iPad charged up. So he said these things saved the day. So moving along real quick, I'm gonna try and do a shuffle here, which way I wanna go. I'm gonna move to the original PMC-8 system that we came out with. This is the Exos 2 GT PMC-8. It is $999.99, so $999.99. Connects the same way. Instead of being that little box built into the computer, this comes with a silver box that connects through 2 USB cables. These are wired so you can't crosswire them and mix the axis up. So you have 2 axes of rotation. Right ascension turning right here, and declination turning right here. So on the one we just looked at, the Exos 100, the largest telescope you can put on it, it's by weight. For astrophotography, we rated it 9 pounds. For visual, we rated it 19 pounds. And that includes telescope and cameras and all that stuff. This model we have rated at 28 pounds for astrophotography, which would be your telescope, your camera, guide camera, all the telescope stuff you put on it, 28 pounds. If you're doing visual with this mount, we have it rated at 48 pounds of telescope and all sorts of stuff. So you can put a really big telescope on here as well. And the question is, will a 127 go on either one of them? The answer is no. A 127 pairs nicely with this tripod. This is the unit I take out a lot of times when I'm using when I have the 127 in the store that I take. The other unit, the Exos 100 that we have just off camera, will not handle a telescope in the 127 millimeter class. 102 probably is the top size of telescope we will say is rated for this telescope. There are customers out there who use on the Exos 100 who use much heavier telescopes with great success. They're good at what they do. They control balance and everything else. So I have one other item I want to talk about, as we always do when we're talking astronomy. The Wiltirion multi-sided, multi-latitude planisphere This has, for the northern hemisphere, it's good from latitude 0 to 60. So with a planisphere, you can determine what exactly is up in the sky. You simply match up the date with the time. So it's January, that's midnight down there. So we're going to come over, let's say we're going to go to January at, it's the what, 13th? January 13th at 6 p.m. just after dark. I'm going to rotate the inner ring to the 13th at 6 p.m. right there. And this shows us what the sky is going to look like at night at 7 p.m. tonight if we go out. That's facing north. If we go out and face south, by just flipping it over, we see the southern part of the sky. So everything from overhead down to the southern horizon is on the back side. By having two-sided, you get a whole lot more detail within the area, so you can see more stars, more detail, things like that. So we're going to go ahead and sign off right now. These products are available at Explore Scientific and other places as well. Go find us and look for our products. So I'm going to throw this back to the control room. Everybody have a great day. Thanks for watching. I'm Kent with Explore Scientific.